All right, guys, so we're going to start with graphing rational functions. We're not actually going to do the graphs today. We're just going to talk about some of the parts of the graph. So when we start to graph them, we can put it all together to sketch. So anytime we're dealing with certain types of functions, we like to talk about how to evaluate, simplify, solve, and graph. So we've done our basic operations, we've done our simplifying, we've done our solving equations, and now we're getting to the graphs. So one of the things is defining what a rational function is. So a rational function is a function that may be expressed in the form of y equals n of x over d of x. And the real important part is to make sure that you have some function of x on the bottom. All right. If you just had a linear function on top and a constant on the bottom, that's actually just a linear function. So you want to have some function of x on the top and the bottom, but the bottom is more important, making sure that you have the x there. Right. And we're going to look specifically where n of x and d of x are both polynomials. Okay, so we're going to use a lot of the properties of polynomials, identifying the degrees, the leading coefficients, and that's going to tell us a lot about the graphs. So domain, that's something that we find for any type of function, being able to identify the domain. And since rational functions are fractions, we have to consider the fact that we're not allowed to divide by 0. Okay, we can't take the square root of negative numbers, but that only comes in when you're doing square root functions. When you're dealing with rational functions, we've got fractions. So really, the domain will be all real numbers except the zeros of the denominator. All right, so we can write it in interval notation, or you can write it using the not equal to sign, but any values that make the denominator equal to 0 are not in the domain. Okay, and graphically, they can be shown as two different things on the graph, but we'll get to that when we start to actually do the graph. So if you're asked to state the domain of a rational function, all reals not equal to the zeros of the denominator. And since the denominator should be a polynomial, those should be easy to find by factoring. Vertical asymptotes. So one of the types of discontinuities that we can have in a rational function are vertical asymptotes. Okay, so that's a dotted line, all right, imaginary line in the graph that the function gets really close to and never touches. But this is technically the literal definition of a vertical asymptote. So if the function, so if the y coordinates go to infinity, or if the function or y values go to negative infinity, as x approaches some constant a from the right or left, then we say the line x equals a is the vertical asymptote of the graph. So what that's saying is if the graph shoots up to infinity or shoots down to negative infinity as you approach some constant, then that's the definition of a vertical asymptote. And the vertical asymptote has to be written as an equation. All right, x equals a constant is the equation of a vertical line. Don't just write the a value. You want to make sure that you write it as an equation. Now, rational functions can also have horizontal asymptotes. So the definition of a horizontal asymptote would be this. So the line y equals b, so that's a horizontal line, is a horizontal asymptote to the graph of the function if the function or the y values approach a constant as x goes to infinity or negative infinity. So graphically, what that means is as the graph moves infinitely to the left or to the right, the function approaches a constant. So the graph levels off at some type of horizontal line. All right. So this is the technical definition of what a horizontal asymptote is. And we'll use these definitions a lot when we start to incorporate limits at the end of the year. All right. And limits are a big topic in calculus that we cover. So knowing this definition, all right, is really closely related to what a limit is. So we have to go through how to identify the vertical asymptotes or the horizontal asymptotes of a graph, and then we'll go through 2 examples. So if you want to move on to the next video, we're going to define how to find the vertical and horizontal asymptotes, and we'll go through 2 examples as well, and then you'll get the assignment.